So we've covered the theory behind networking and APIs, and we know from the documentation that the request to OpenWeatherMap consists of a base URL as well as three parameters: the latitude, the longitude, and the app ID. The good thing about OpenWeatherMap is that they have a free tier and that we've already created an account. If you scroll to the top of the weathercontroller.java file, you will see two things. The first is that base URL that we'll be using to make our API calls, and the second is that free account's app ID, and both of these are listed as constants at the top. Okay, so we've got the base URL, we've got the app ID, we need to supply two more parameters, namely the longitude and the latitude, which we extracted from our location object. So now we're going to take this app ID together with the latitude and longitude and bundle them together. Inside onLocationChanged, create a new variable called params. This variable will hold the query parameters for OpenWeatherMap. That request params class comes from James's handy networking library, by the way. The way to add each of these parameters is with the put method. And the put method requires two things. It requires a key and a value. The key for the first parameter is the parameter name, in this case lat. And the value for the latitude is the string we've extracted from the location object. In the same manner, let's store the other two parameters in the params object. We're going to put the actual networking call into a separate method. Add a call to a method called let's do some networking and give the params as an input. Add this new method below the corresponding to-do. To fetch the data from the internet, we're going to need help from a special object that helps us with the ins and outs of networking. This is where James's networking library comes in handy once again. Create an object of type async HTTP client named client. Remember how we said we won't be typing any code into a browser? Instead, to get the weather data, we will need to perform an HTTP request, and James's library will help us make these HTTP requests and simplify the networking for us. The great thing about this library is that it takes care of doing the time-consuming network requests in the background. This means our app remains responsive while it's waiting for data from the OpenWeatherMap server. If our networking code wasn't being executed in the background, in other words, asynchronously, the app would completely freeze until the response came back from the server. But with the async HTTP client object, we don't have to worry about any of that. In fact, we're going to use it to make a GET request. Simply type client.get and supply the three parameters. The first is the address or URL of where to look for the data, the weather URL. This is the string that we've saved in the weather URL constant. The second are the query parameters used to make the API call. These are the parameters that we're supplying as an input to the let's do some networking method. At the moment, this is the longitude, latitude, and the app ID. And lastly, we need an object that will be notified of the response to this GET request. The component that will be listening for the response from the server is an object of type JSON HTTP response handler. And you guessed it, this class is also from James's library. The JSON HTTP response handler will receive one of two messages, on success or on failure, depending if the GET request was successful or not. And just like with all the other callbacks that we worked with, from the button's onClick method to the location listener's onLocationChanged callback, we will need to specify exactly which instructions should be executed in each case. Time to add that code now. Use @override to redefine onSuccess for the JSON HTTP response handler. The onSuccess callback is triggered when the request is successful. But at this point, Android Studio will ask which header we want to use. The reason is that the name header is just a short name. It turns out there's more than one component that we could be referring to as header, so we need to confirm the component's full name. Move your cursor to the red text and press Alt-Enter on your keyboard. Now out of these three choices, make sure you use the czmcebera.android.httpclient.header. In my case, it's the third one down. So what did we just do? Some Java classes have the same short name, so we need to specify which class we're actually talking about. We can see all the full names of all the classes that we used at the top of the file. There, the import statements show us the full names of all the components. When we click the little plus sign, we can reveal the full list. These import statements allow us to refer to the short name instead of the full name of any of the components. And there we also see the latest addition, the cz mcibera.android.hdpclient.header import statement. We also want certain bits of code to be executed when the JSON HTTP response handler reports back to us if something went wrong with our HTTP requests. So let's override and add the onFailure callback. This method will be triggered when the GET request was unsuccessful. And inside onFailure, let's add a log statement to show the detail of the error in the logcat. And to do that, we're going to take that error object, e, and turn it into a string and print it to our logcat. And the other thing we're going to do is we're going to print the status code that got shipped with the onFailure method to the logcat. But since any user of the app won't actually see what's going on in the logcat, we're also going to add a toast message so that they can monitor the outcome of the request when the app is running. So we're not going to actually do anything special when the request fails. We're just going to print out the error message and inform the user that something went awry. On the other hand, if our request was successful, we're going to get back some weather data. So let's add a log statement inside onSuccess to print our weather data to the console. All the weather data that we're getting back is stored inside the response object. To print that weather data as text on the console, all we have to do is write response.toString. Now let's run the app. Time to find out if that networking call will be successful or not. Since you might be getting a lot of log messages, configure your logcat so it filters by debug messages and by log messages that include the word Klima. If all goes well, you should receive your onLocation changed callback along with your latitude and longitude. When this information is passed to OpenWeatherMap, you get back a whole bunch of data in the form of a JSON. If, like me, you're using the emulator and have to play GPS, click the 3 dots, supply a new longitude and latitude, and click Send. In the next video, we're going to make sense of this army of curly braces, quotes, and colons that is our weather data. I'll see you there.